Hey guys, Ty from Ty Geeks Out. Let's talk about inverse sine or arcsine in trigonometry. So in order to understand what arcsine is first, let's just first understand what sine is. So very basic overview here. Here's the y-intercept, x-intercept, little review. Sine starts here and it goes like that, and then it continues onward like so. This isn't verbatim, but this is the general shape. And in order to know the arcsine, pretty much what that is it's the opposite. So the opposite of this graph would be like so. Well, that's kind of crappy. Let's back it up here. Oop. And a little bit better, but you get the gist. It's pretty much this sine wave going, instead of from negative x to positive x, it goes from negative y to positive y. So my drawing is horrible, but let's get a picture because pictures are cool. I didn't make this, got it off Google, but a clear demonstration. So let's I'll add on to this. So here's a better to scale version of what I just drew. But as you notice, this doesn't continue on forever. But let's just pretend it did. Boom, boom, boom. Oop, how did that happen? Let's get it back up here. I think I pushed undo by accident. There we go. Okay, so here's that. We'll pretend the wave goes on forever. Let's get a matching purple color. There we go. And this can't go too far, but you get the idea. So here's a more to scale version of what I previously drew. It goes on forever from negative x to x and negative y to positive y. But in order for this inverse to work properly, it needs to be a one-to-one function. And in order for something to be a one-to-one function, there is what we call the horizontal line test. And we'll get black. There we go. So as you'll see here, if we used sine going from negative x to positive x, it would hit multiple points. There's one there, and eventually it'll hit right there. So, okay, we can't use this because it's not one-to-one if we do it this way. If we do it, this way, let's just pretend that this wave we see here in purple is now in blue is now the purple one. If we, do the vertical line test, which is just to prove if something is a function, it doesn't work either. You're going to hit the point here, and eventually you'll hit pi up here. So it won't even be a function if we, turn it on its side. So this is why the domain and the range are limited to negative pi over 2 to pi over 2 and pi over 2 to negative pi over 2 on the y-intercept. So let's get that image out again, and I'll just to make it a little more clear. So yeah, the domain it's limited. So anytime you're dealing with arcsine, it's limited to right there and right there. So the graph, it's a nice way to understand what it's trying to do. Arcsine is, going from negative y to positive y to just these points. But I actually have a little cheat sheet way in order to understand this better. So the rule with arcsine is it's limited to the first and fourth quadrant. Let's draw that. Forgive me, I hope I can draw this well. It's looking okay. All right, it's all right. Okay, so if you remember, it's quadrants 1 and 4. So I said the domain both domain and range are limited to negative pi over 2 and positive pi over 2. So just these quadrants though. So don't worry about this stuff right here on the second and third. So let's get the values going. So of course we have the x-intercept, which is 0. So, you know, this is 0, 0 right here. And yeah, this is just equal to 0. So you got to know the unit circle pretty well to understand this, but I'll do a little review. So pi over 2 is just 90 degrees. So we got 90 here. But if you see here, there's a negative pi over 2. So what does that equal to? Probably negative 90. Okay? So if you can see where this is going, everything here will be negative, everything will be positive. So we have pi over 3, pi over 4, pi over 6, and then it continues onward, negative pi over 6, negative pi over 4, and negative pi over 3. So where I got these numbers from, they represent what angles they are in radians. So I said pi over 2 is 90 degrees. How did I know that? Well, if you remember your angles, 90 degrees is a right angle. So if you look here, 0 and straight up 90 degrees. Same over here. Let's do a different color. We'll do blue. So if you look right here, let's try to do well with this. Okay, here's another angle. So here was 90. So it's less than 90 right here. So on the unit circle, the standard for pi over 3 is the 60 degrees. So here's 60. Now let's do it a little bit more right here. So from the green line to the black line, that's 45 degrees. And we'll do the last one. Let's do purple. You can see here it's getting smaller. It's getting shrunk. It's shrinking, excuse me. Pi over 6 is 30 degrees. So how I like to remember these, it's pretty easy. Just a given, pi over 2, 90 degrees. 45 degrees is really easy to remember because you associate the 4 with the 4 on 45. The 60 degree and 30 degree values are just reversed. So pi over 3, 60, pi over 6, 30. Just take a little bit of practice, but you'll get there. And of course, all this stuff mirrors down here, but it is negative 30, negative 45, negative 60. So yeah, we start at 0, go negative, start at 0, going up, we're going positive because positive is up here, negatives down here. Okay, so we have our cheat sheet. Now let's get a inverse sine function going here. So I got group black, cool. All right, let's do sine, inverse sine, 0. What does this equal? Well, we know first off that sine equals y on the y-intercept. And that's no coincidence that we're pretty much dealing from one y-intercept to the other here. And we're not really dealing with any of the x over here. So if it says sine, the inverse of sine 0, well, we just look at the 0 point right here, and we move it all the way over here, and we'll see that it's 0. So that may have not made sense, but if you just bear with me here, we keep going, you can see the pattern that begins to unfold. So let's do arcsine -1. What does that equal? Okay, so again, y is sine on the on the graph here. So where is negative 1, y equals negative 1 on the graph here? Well, here's the intercept, the y-axis, y positive. Let's go to y negative. Oh, look, negative pi over 2. And that is our answer. Seems fun, not too hard, not too challenging. Let's do a little bit crazier one. We'll do arcsine square root of 2 over 2. Now, oh, goodness gracious. Square root of 2 over 2, scary number. But, you know, it's actually not too bad. Just by looking at the unit circle, I didn't draw it over here, but we know, just as a given rule, anything square root of 2 over 2 is a 45-degree angle. Remember that. Anything over square root of 2 over 2 is 45 degrees. So it says square root of 2 over 2, and it's positive. So where is square root of 2 over 2, which equals 45 degrees? So a positive 45 degrees. Where is that on here? Right there, 45 degrees. So this equals pi over 4. Let's try another one. Arcsine negative square root of 3 over 2. Okay, so again, kind of scary. But let's just dissect this and see where it goes. So first off, it's negative. If you've been paying attention here, 0 is neither negative or positive, so that's why it's right in the middle between negative and positive. We said negative pi over 2 is down here, so this is the negative realm. Pi over 4 is up here, positive realm. So negative square root of 3 over 2 should be over here, down here in the negative area. Going back to unit circle, if you want to know what this is, I mean, you have to know what it is, and I'll probably do a video on what the unit circle is, an easy way to remember. But this is equal to 60 degrees, square root of 3 over 2. But there's a negative here, so negative 60 degrees. So where's negative 60 degrees on the little cheat sheet we drew here? Oh, right here. So we'll see here that the answer is negative pi over 3. And we'll do one more. Arcsine square root of 2 over 2, negative square root of 2 over 2. Okay, so what do we remember from up here? Well, first off, we'll just use the old answer, pi over 4. If you don't remember, 4 is associated with the 45 degrees, so we know that this is 45 degrees. Where is 45 degrees? Right here. But where's the negative 45 degrees? Right here. So we know that our answer is negative pi over 4. And we are done.